So today we're going to talk about consequences of groundwater withdrawal, since as we've been talking about, groundwater is one of the main sources of fresh water out there. We're going to talk a little bit about the consequences of withdrawing more groundwater than otherwise. I'll talk later on next week about the issues associated with overdrawing rivers, lakes, some of our stuff, so just so you know. So where does most of our groundwater go? Now this graphic is a little old, but it still gives you some of the trends that are out there. That groundwater really is coming from mostly for irrigation. So what is that irrigation for? For our food. So a lot, and I'll talk at the end of this lecture about the hidden water in our food, that every time we eat anything, how much water goes into being able to create that food, and how we really kind of need to change some of what we're doing in order so that we have better food supplies and think about what we're eating and maybe the water, the consequences in it. Other uses for water is public supply. So if, like I've mentioned multiple times, the city of DeKalb and the whole of DeKalb County gets all of its water from groundwater. So that's public supply. Industries, a lot of industries use water on their own. Now, when we say industry, we can also be talking food. So bottled water. Where does bottled water come from? Well, bottled water, if they're getting groundwater, and a lot of them are, you can talk about the issues with like Nestle in Michigan, where they're depleting aquifers in order so that you could have bottled water. So industry could be that, or it could be something like Coca-Cola. There's some work I've been working with on Coca-Cola and getting groundwater so that they can make their products locally. So that's some of their issues. And then rural water supplies. If you live out in the rural communities, you're more than likely drinking groundwater. So what are some of the main issues with this is lowering of the water table. So we mentioned how deep is it down for groundwater around here? 3 to 6 feet. Some areas it's much deeper. We talked about Yucca Mountain, very deep down. So one of the things that we can look at is that water tables will get depleted. I used to live in Arizona, so I went to high school in Arizona, in Peoria High School, so not Peoria, Illinois, but Peoria, Arizona. And I went to the University of Arizona. Well, when I did my undergrad there, one of the things that we talked about was a lot about cactus and desert landscapes as part of my biology classes. Well, the water table has dropped down, that the deserts used to be a lot greener. There used to be water that flowed through some of the rivers all year round. Because we've depleted those aquifers and we're draining that water, we're lowering those water tables down to almost where it's actually damaging the ecosystems, not just for humans, but also for the ecosystems in there. This graphic here is talking about different types of groundwater withdrawals. So the areas that are in the orangish color, right in here, these actually have massive amounts of groundwater withdrawals. Parts of Texas are going through massive, especially Ogallala Aquifer, which is right here. Massive decreases in water. People are fighting over it. I mean, there's been movies about getting water and where we're going to be going, and this is causing a lot of problems. And as we mentioned, this is not something that it crosses boundaries. It doesn't stay in one state. So a lot of times we have to drill deeper and deeper, so it costs more money to get to the water, and we might be even getting into lower quality water. We might find a really good aquifer somewhere, and once it's depleted, it's gone. Well, what can happen when we deplete aquifers? Well, one of the big things that can happen is compaction and surface subsidence. So in between each of the grains, we can put water that holds those grains and holds that system up. If we deplete all of that water and we suck it completely dry, well, those grains don't have anything that helps to support them where they are, and they start to collapse upon each other, and they get more and more compaction occurring. And so this is called subsidence. The ground level is actually decreasing and going down with time. So like in this picture here, this gentleman was showing where the ground surface was, like a true elevation, in 1925, then 1955, and 1977. And this is in the San Joaquin Valley. Why do we know the San Joaquin Valley? Well, it's where most of our food comes from. It is a major area where we're depleting aquifers. We're sucking up all that water to get into our food supply. I'll talk about almonds and how much water goes into almonds, and Don't drink almond milk. Okay, you remember my whole thing yesterday about the Fiji water? I can go on a whole tirade about almond milk and everything like that. So we'll talk about that later. Yeah. So okay. Sorry. What it does is, as we have that compaction, we're going to have that decreasing permeability. So less, if you guys remember the difference between porosity and permeability, the porosity hasn't changed. We've sucked all the water out of the porosity, but the permeability has changed. So how easy can that water go? And then we have structural problems. There is issues with different places that, ground has changed into there. I'm going to pause the video right now, and I'm going to get some pictures from Mexico City and show you some of the differences in there. So I am going to post a video online. You'll see this one right here. It is called Mexico City is Sinking. I will post this on here. It's a really good video showing some of the issues within Mexico City. I mean, such as this monument that's in downtown Mexico City. It used to have 9 steps. Now it's got like 23 steps because of the ground sinking around it due to subsidence and due to overexploitation of the groundwater, and also changing the hydrogeology of the area. So you must watch this video and take notes on it. It is part of the lecture. While Mexico City does have some of the major issues, this is not just an issue with Mexico City. This is also Galveston Bay, San Joaquin Valley, as we're showing here. This is a common problem in a lot of areas when we de-water our aquifers. And so I like using Mexico City as an example because it really is quite dramatic what is happening, especially when it comes to water issues. One of the other things that we can have when we have major water issues is what's called saltwater intrusion. Saltwater intrusion. So we don't have that problem here per se, and I'll talk a little bit more when we get to the Illinois section of this class. We'll talk about water issues in the state of Illinois and what's going on here. But we don't live near the ocean. So if we live near the ocean, we might have major problems with saltwater intrusion. So what it is saltwater is more dense, or denser, I should say, than fresh water. So it goes below it, and fresh water sits on top and salt water is underneath it. As we are living in a coastal situation, we want to drink that fresh water. So we are drinking that water that's pulling on the top, and since we're decreasing the amount of water there, we're pulling water into our areas. And if we're in a coastal area where there's salt water, we're going to be pulling in that salt water, and our wells might actually turn what's called brackish. Brackish means that it's slightly salty or getting saltier. It's usually over 1,500 microsiemens per centimeter for conductivity. For you guys who know water quality, what that means. It starts to get saltier tasting. You can't drink it and can't consume it. And then once that saltwater intrusion occurs, it's really actually hard to push that fresh water back out. We would need massive amounts of water coming in on top of it, such as like maybe a hurricane might put in, but really those don't even really help because that water is flashed inside of it and it doesn't seep in or recharge into the ground. It's really hard once we get the saltwater intrusion occurring for it to reverse itself. We could go into desalinization when we talk about water treatment. We'll talk about some of that later on, but that's very expensive. So as we have in this figure here, what we're looking at is we got the fresh water on top of salt water, and we've got our water table here, and then we put a well in. Well, that forms that cone of depression, and if we put it up here, we're going to draw that salt water in from that oceans underneath it into there. And once we draw that in, it's really hard to move it out. And so this is a major problem for coastal communities, that they can't drill deeper. It's not like here where, I mentioned Arizona earlier, or even here, we'll just drill a little bit deeper to get more water. Well, you drill too deep, you're going to hit salt water. So this is a major problem also like in Cancun, where they only have about 10, depends on where you're at, 10 to maybe 20 meters of fresh water sitting on top of saline water. And they can only drink that fresh water up there. And so it can cause problems. And so this is a major problem with overexploitation of our groundwater. One of the other issues is urbanization, as we put in impermeable surfaces. So if you guys go over to any of the, Lowe's, Home Depots, any of the modern, strip malls, they always have these ponds that the geese are all at. There are always geese there. So these ponds, what they're really for is for runoff. So we have to put in giant parking lots next to the building. So I'm going to take an example like Lowe's. Why do they have such a big parking lot? There is never that amount of people inside of that store. Well, building code requires that whatever size store it is, it has to have a certain size parking lot. So that's why we have these humongous, impermeable surfaces associated with these really big box stores. These big box stores also have impermeable surfaces across the thing. So we end up with all of this space, with all of this area that could be used for recharge is now impermeable. So what happens is they put in those retention ponds so that all the water that hits it can go somewhere and then slowly infiltrate into the ground. That's what those retention ponds are for. So that all of the debris that's on top of the parking lots, we call it first flush, is when the first water hits the ground and then it takes up all of that oil, the leaking oils that you guys have from your cars, all that dirt and grime, there's radiator fluids, whatever you've got on there. It's on the pavement. It needs to be moved and gets into those retention ponds. The idea with the retention ponds is that they've got a clay lining, and then we decrease the permeability. Again, remember I talked about how soil can act as a filter, so the water will slowly go through it and it will filter the water down inside of there. But we change how much hydro we have when we build up cities. But there's always an interesting thing about urbanization. So what happens if we have leaking sewer lines or leaking water lines? So we always put our sewer lines underneath our drinking water lines. So our drinking water lines are here and our sewer lines are here. We do that because you don't want your sewage leaking into your drinking water. And they're under positive pressure, so the water wants to come out instead of stuff coming into it. But those water mains, if they break, then that water can actually recharge as part of the aquifer underneath the city. So sometimes, depending on the infrastructure, you could actually have a lot of recharge due to just the water that has already been treated and clean going back into the aquifers. A lot of times in the United States, our infrastructure is getting D ratings, F ratings because they're failing. It's just that people don't see it because it's underground and, they don't notice that this is just falling apart. We really do need to take care of our infrastructure. So when we talk about urbanization, when we talk about water resources, we're talking impermeable surfaces, we're changing amounts of recharge. And one of the main issues we have here in Illinois is filling in wetlands. A developer wants to build a complex, a housing development in this area. They own this land. Well, if there's a wetland there, they can fill in that wetland and then put in a new one somewhere else. The hydrogeology of the system just doesn't work when you change the location. The hydrogeology and the geology and the way the water's flowing in the hydro inside of wetlands really is unique to that location. There's a reason why that area developed wetlands. And so by changing the hydro, by changing the system, by filling in, you're going to be changing this. You're not going to get the same thing by trying to build a new wetland somewhere else. It's much better to keep your old wetlands and then not leave your wetlands alone. That's where we recharge our water. It's a great place for filtering our water, cleaning it up, creating ecosystems. So wetland delineation is a whole job that you could do. There are classes here at NIU, and there are surveys that you can take and courses you can take beyond your college degree in order to become someone who does wetland delineation. It is a job where you go out and delineate where they are, how healthy they are, what types of plants, the hydro behind it. I'm working on one project up by Woodstock, and that one has a lot of rare plants inside of it. Well, I'm not a plant person, but I'm a water person, and these things work together. You can't study a wetland without understanding the hydro, the water movement, if you want to understand the plants. So understanding how groundwater moves and works is critical for our understanding of how wetlands work. I'm going to stop there and then talk about other geology.